Well, welcome everyone to the first in a new series of webinars from Port Technology International. My name is Beth Maundrill. I'm the editor here at PTI and I am going to be moderating this webinar. The webinar will cover artificial intelligence and resiliency, looking at how AI can be leveraged in today's climate to enhance port operations. As we know, ports and terminals today have more information and data than ever before, and AI is being used increasingly to work through that data. With the use of AI-driven models, users can look deeper into their operations and more accurately plan equipment deployment, which of course provides advantages during uncertain times such as these. So before we start with the presentations, I'd like to take a moment to thank our sponsors, Inform and TBA, both of whom you will be hearing from today with some really excellent presentations. And just before I introduce the speakers and the presentations, some quick housekeeping for our audience. Thank you for joining us. And what we will be doing is we will be hearing all of the presentations first, then go to the live Q&A session at the end with an aim to conclude at around 3:15 British Summer Time. If you do wish to submit a question anytime during any of the presentations, please use the question tab on the right-hand side of your screen. We will try and get through as many questions as possible, and please do let us know who you would like your question directed towards when you ask it. Now to our speakers. We have a really great lineup from some really excellent presentations from experts in the industry. We will be hearing from Robbert Engels, Director of Product at PortXchange, who will explain how AI is used at the Port of Rotterdam and beyond. Dr. Eva Salvesberg, Senior Vice President for Inform Software, who is going to explore the value of data today and in a very interesting way indeed. Joining us once again after a successful webinar in March, Dr. Oscar Pernia, Director of Automation and Process Engineering at Terminal Investment Limited. He will be looking at how AI can enhance our container planning operations. And finally, we will be hearing from Dr. Csaba Boer, Chief Product Officer, TBA, who will end the session with a presentation on predictive maintenance and what that can mean for your port operations. So first, we will begin with the presentation from Robbert Engels from PortXchange.
Good day, everyone, and welcome to this webinar. My name is Robbert Engels, and I'm the Director of Product at PortXchange, which is a spin-off from Port of Rotterdam. Today, I want to tell you more about artificial intelligence as a flashlight for port operations. I'll explain how we use artificial intelligence in the Port of Rotterdam and other ports. If you take a look at the field of artificial intelligence, there's a huge amount of tools and techniques available, like deep learning, neural networks, natural language processing, and many more. So where to begin, or how to apply this? Let us have a look at this example. At PortXchange, we create value by helping port communities improving the planning and monitoring of the port operations through real-time visibility. In this example, the Port Authority, the terminal and an agent are aligned, sharing the same information on the planning of a ship. However, the pilots and hinterland trucking company do not have direct access to the information and all the updates in planning. High-quality data is not always available for all actors, due to commercial, technical, or operational reasons. They are kept in the dark. So how to get this high-quality data? And this is where AI comes into play, to shine a light on these dark spots. We use artificial intelligence to create data that is not available. We call this derived data. With available data from other sources, this can be real-time or historical data, we can create new data. From the umbrella of all the AI technologies you just saw, we use machine learning models. We use available data, for instance AIS, to derive and predict events. One of the events that I'd like to shine a light on today is the arrival time of vessels. Let me explain how these machine learning models are actually generated to create these predictions. So say you want to predict when a vessel arrives at a port. Well then first, we need to locate the vessel and know our destination. Then we need to forecast the route to the port. Our pathfinding engine uses graph analysis in order to do this. This is similar as to car navigation. We take the vessel characteristics into account and then determine the possible routes to the port. Then we will need to implement a machine learning model for the predictions. This model is trained using millions of AES messages broadcasted by vessels that already visited the port. Here you see an example of a graph network we use to plot the expected vessel route to a port. We use so-called supervised machine learning to generate these travel time predictions. Meaning, we use historical data with input and output to train a model. You can use all kinds of input to train your model. AES messages, the next port of call, the route, vessel characteristics, weather, or other characteristics that you deem interesting to calculate the travel time. And then you create a learning algorithm out of this. You can create your model, and with that model you go into the next phase. You go into the prediction phase, actually using the model. And then again, you use your live AES messages, your live feed on the next port of call, the vessel characteristics, you put them into the model, and then the model will calculate the travel time in real time. So, coming back to the example, we still have the port authority, the terminal, and the agent sharing information. However, the pilots and the hinterland trucking companies did not have access to the information and all the updates in the planning. Now, with the output of the machine learning models, we can provide data, share information on planning of a vessel, which allows them to plan better. Now, this might not be the direct source of information, and it might not be the best quality of information available, but it is already a lot better than merely guessing or doing no planning because information simply isn't there. So you get this new situation whereby the pilots and the trucks are making use of the outcome of the machine learning models for their planning, and the other actors are still sharing together. Now, ideally, you would want to combine this information. So pilots and trucks also get access to the direct sources of the information, but also the port authority, the terminal and agent, getting direct access to the machine learning models to help them improve their planning as well. But there is more. If you have actors that are already sharing data on an ETA berth, for instance, you might say, well, the ETA berth is 2100 based on these direct sources. Now what you can do is you can apply AI together with the historical information you have available on these direct actors, on AOS positioning, and other potential sources you have to further improve the reliability of the predictions. Often enough we see that this depends on the port or the terminal, the trade, the companies, the actors. There are a lot of different situations whereby in one situation the agent has the access to the most reliable information, while in other situations it's the terminal or the port authority or another actor in the port operations. By aligning these different data sources and combining this in an AI model, you can start improving the predictions and come up with the most reliable prediction on the arrival time, for instance 2130. These techniques can be applied to all sorts of missing data in the port operations all over the world. Now, can you always apply AI in these situations? Well, I would not recommend it. Basically, garbage in is garbage out. If you cannot find proper sources of data good enough to educate your models, then the output is unlikely to give good results. Thank you for your attention on this brief introduction in AI for ports. I hope you found this interesting, and I'd be happy to answer any questions afterwards. Once again, my name is Robbert Engels from PortXchange. PortXchange provides a platform for port optimization. So are you interested in optimizing your port operations or reducing emissions in shipping? Don't hesitate to contact me or visit our website. Have a great day. And once again, thank you.
So thank you so much, Robbert, for that and shining a light on how AI can be used in port operations. Again, for the audience, if you have any questions, please feel free to submit them in the questions bar, which you should see on the right-hand side of your screen. Next, we'll hand over to Dr. Eva Salvesberg, who is the Senior Vice President from Informed Software.
Thanks for the introduction. Join me on a short journey through time. History is a great well to find patterns which help us to learn for today. This picture might be quite surprising for you. It's kind of basic stuff, screws and screwdrivers. But precious if you're woodworking, and fascinating if you look at the history of tools. Despite having been invented as early as 400 BC, the screw wasn't prominently used in any industry until early 1930. 1930, that's kind of recent. Early screw-driving tools can be found around 1400, quite late compared to the early usage of screws. Screwdrivers more comparable to the ones we are using today, appeared around 1700. But the magic happened when a co-evolution between screws and screwdrivers appeared. In the beginning, those were bespoke tools, quite expensive and quite specifically used in different patterns for different usage. And then kind of a industrialization picked up. The screws were more produced for a big output, for automated output. The screwdrivers were shaped in a way that they could be used swift and easily. And so together they made a team which was unbeatable. Traveling further in time and coming closer to today, when we look at the year 2012, the amount of data at that time was something like 1 zettabyte. 1 zettabyte, that's quite big. It's 21 zeros. But only 22% of this data was considered to be usable. Coming to today, we have something like 40 zettabytes of available data, and 37% of this appears to be usable. But still, a zettabyte is a bit beyond our power of imagination. So let's stick to where we come from and bring it back to our domain. If you look at a, let's say, medium-sized port, which might have a logistics system, a software in place. This software writes between 1.5 or 2 gigabyte of compressed log data per day. This amounts to 0.5 terabyte per year, compressed still. And roughly the 10-fold amount of this uncompressed. Again, let's do a comparison, makes it easier. If you look at the complete work of Shakespeare, this would occupy 5,600,000 bytes, or 5.6 megabytes, when written in plain and uncompressed text. In other words, the software we were looking at writes 1 million times the amount of bytes of the complete works of Shakespeare every year. Artistic quality might be another issue, but that puts into perspective how much data we are gathering year per year, and also how much data is there to be used. Now we have the screws kind of in place, but we also don't want to fasten each and every screw with our hand. Our hands are so capable. We can learn to play instruments with great artistry. But if you would have to take let's say, to build a house and screw every and each screw by hand, that would take an enormous amount of time. So we don't want to do that. But we have tools in place, like screwdrivers instead of hands. We also have machine learning and operations research in place to help our brain to weed through this huge amount of data and to find knowledge in this data and use this knowledge. Machine learning can help us to learn about the past and take these learnings to operations research and take this tool to help us to bring strategies in place to optimize processes, to make decisions today and for the future. Customers of ours like DP World, it's our newest customer, take those powerful tools to improve their logistic processes. A long-time customer of ours combines our machine learning tools together with our operation research tools to improve the whole logistic on their ports. But today, the industry knows that they have to take it a step further. We have the screws in abundance, but we still lack logistics. What do I mean by we lack logistics? I mean, we have this great ports with this great logistics. Very true. But we still have a bad logistic with data management. We need a professional data management, a professional data logistics. We need the planning, the coordination, the provision, the control we are used of in professional logistics. And we have to put this in place with data management so that we can make use of this very, very precious resource, the data. We have to get the standards in place and we have to clarify the ownership of data. To bring those three together, the machine learning for learning from the past, the operations research to bring in the strategies to put them in place, and as a backbone, the data management. This can really give us the power of data, the power of the usage of data for our processes. The Port of Rotterdam has undertaken an impressive project, the Container Exchange Road. Optimization and later machine learning based on a professional data management, and those will go hand in hand and make this challenging project possible to have this great logistics in place at the Port of Rotterdam. Let's go back to a broader picture. The growth of containerization had its ups and downs over, let's say, the last decades. Tools like machine learning and operations research combined with data management will give us the ability to cope, sure, as far as possible, but to cope with those changes. Imagine industry with a lacking of data, of logistics, and with a lack of appropriate tools. I mean, that wouldn't work. And so as I said before, if you have the data management and if you have the tools in place to manage this data and to get the benefits out of this data, that will give you resilience for the future. And the co-evolution of those tools and of the data management is the same as it went on with the screw and the screwdriver. There had to be a paradigm shift from the bespoke tools to this co-evolution and going ahead in mass usable tools as we have them today. And in the same way, we have to enter a stage where we can use easily and readily data with appropriate tools. And let's going back in our mutual history to Mr. McLean and his concept of containerization. This paradigm shift as well gave us the possibility to have ports as we have them today and to have this great logistic for goods and kind of to live in the world we are living in today. So we have to undertake the same paradigm shift of the co-evolution of those different parts to be as successful in data management as we are in port logistics. Thanks a lot, and I'm looking forward to the next presentations and to the questions and answers afterwards. Thanks a lot.
Well, thank you very much for that, Eva. Always great to hear from Inform, and you always have a really interesting approach to explaining what are very complicated topics, of course. So next joining us will be Dr. Oscar Pernia from the Terminal Investment Limited.
Hello, everybody. Thanks for technology for the invite. It is great to debate about this topic, which I strongly believe is part of the future for container shipping. My presentation is a humble reflection about that future, but highlighting the still hard work to do and the many challenges we need to tackle in order to get there. Moreover, it is truly an honor to present along with these speakers, people that I know from past and from current projects, who I consider partners to move application and practices, but also mindsets in our industry. My presentation is focused on terminal and carrier planning processes. When talking about planning, we are in front of several decision domains. Already at terminal side, as with berthing, vessel, yard, and intermodal planning, but also the connection of those with processes at ocean carrier side, like stowage, marine, or port call planning. With the increasing size of vessel and the associated operation at terminals, the planners are dealing with much more complex and multidimensional problems, and in a much more real-time and connected environment, without enough evolution from the systems supporting those decisions and the integration between them. In the diagram, I illustrate some of those processes and the decision-making points where the correlation of information from one process to another help establishing the critical trade-offs. Being the decision-making very connected and based on forecasts, as for example, guns deployment by vessel planner with the crane split by stowage planner, or the estimated time of arrival by port captain with the estimated time of berthing by berthing manager. Similar for the estimated time of completion for cargo operations with the coordination of services to enable vessel departure to meet the estimated time of departure. All very related to end results KPIs like vessel port stay. Or berth window allocation by berth planner with the yard space allocation by the yard planner, or the next container connection or appointment by the rail or gate planner. All very related to another end result KPI like container dwell time. So, how to generate planning, learning, and execution feedback loops? At planning, decisions are based on repetitive patterns. And indeed, what planners apply is the human experience in most of the cases. Very often with data that is not accurate or has some bias. At execution, the difference in performance is mostly determined from how sections are managed and how effective are your contingency procedures. Container shipping is a plan B industry, so that's why. The diagram illustrates the planning and execution decoupling with the learning feedback loop and the parameters at planning part and the contingency procedures at execution part. So why proposing artificial intelligence to improve and connect planning and execution? A, to enable the whole planning system to look ahead, creating feedback loops and being prescriptive to forcing bottleneck or optimization opportunities. And B, to enable educated decision making, to manage exceptions, and making contingency management quicker and more robust, and making execution more adaptive and resilient. Then why AI for container shipping? Getting back a bit to the theoretical whiteboard, when looking at the value proposition from artificial intelligence and its fields like machine learning, we have a very good match. For planning, pattern recognition to identify best previous applied strategies and decisions. As for segmentation of the decision domain or recommendation to the planners, data-driven predictions to be able to look ahead. As for forecast and regression that allow better anticipation and coordination. For execution, more on the adaptation when something does not go according to the plan, as for problem detection. Also self-learning and understanding of the reality in front of us, as for problem diagnostics. And both for planning and execution, deep analysis and correlation across domains and recommendation to the users are very important, as for planning parameter setting, real-time decision, or learning task. All this responding to very complicated, dynamic, and changing environments like the one we deal with in container shipping, both at terminal and carrier side. But we need to look at the constraints from the current technology landscape. I know we are still early in terms of adoption to create a real impact from AI, but indeed the technology is evolving very rapidly and there is a core foundation that has to be built. So on that path, first, we need data to be available and to be open. The data today is still in silos. It's not usable, not enough, not structured, not labeled. We need the data to be accessible. We need the data to be standard. We need the data to be structured, to be contextualized. That's what I meant with the label. Only in that way we can make it useful for applying AI and machine learning successfully. And in that path, the suppliers need to open the data models and being able to standardize the APIs. Second, we need to move towards to a connected, intelligent ecosystem. Today we have algorithms, a lot of them very effective when they have the right input. But in general, algorithms do nothing without a clear direction. They do only what is written in the code, and they start from zero every time they run. And those are limitations to be effective in our application at container shipping. Also today, those algorithm decisions are completely scattered in different systems. And we have very difficult to leverage historic information and data from one application to another. An example is automated planning. It's been tried several times, but we still have isolated and myopic decisions for each process. Even within the same software product, as for combining the chart, decking, grounding decisions with the loading, selection, vessel stowing decisions, those software modules are disconnected when the problems that they are solving are really related. And then a fundamental last note from my side, how to organize around AI. The biggest barriers companies face in extracting value from automation, data, or analytics are organizational barriers. Due to the challenges to introduce a process-driven and data-driven approach. Imagine with artificial intelligence, which is changing the whole thing. Some areas to focus on to be more concrete. For terminals, the boundaries between operations, IT, and maintenance needs to be removed, as the whole terminal system will be behaving as one single thing. Second, we need to record the user interaction and create analytics around it. We need to analyze how the users behave. This is for helping the system to better support the different functions, but also to be able to leverage the learnings from the best performers' practices. And third, the new roles and competences will need to be incorporated to take care of the data and to take care of the algorithms. This will drive the successful implementation of AI. The diagram illustrates that operations, IT, and maintenance triangle, and the different AI-related competences. There are more, but this is just some of them. And then some conclusions and takeaways. The first one, to make planning more connected, dynamic, and resilient is today a must for terminals and carriers. Second, artificial intelligence and its different fields like machine learning already provide the capabilities we are demanding to do so. Third, current constraints for open and standard data, myopic optimization, user interface analytics need to be resolved with the technology suppliers. And last but not least, the terminals need to remove organizational boundaries and introduce the new roles and competences to truly leverage artificial intelligence. And to finish, while I am not a very friend of using a statement from others, this is from one of my favorite scientists, very related to this presentation. Intelligence is the ability to adapt to change. Stephen Hawking. And in our industry, that's the game about. I believe in the future AI will help to have smarter, but also more connected and more transparent terminals, and also creating much better working environments, safer, more secure, and more sustainable for everybody. Thank you.
Thank you for that presentation, Oscar. And just a reminder to our audience, please do continue to send in your questions via the question tab on the right-hand side of your screen. We've already got some great ones coming in from some familiar faces and from some new audience members. Finally, we're going to head over to our last presentation from Csaba Boer, Chief Product Officer at TBA, who will be looking into predictive maintenance and what that can mean for your port operations.
Good afternoon, ladies and gentlemen. My name is Csaba Boer, and I'm part of TBA Group. Today, I would like to give you a short presentation about an AI application that we have developed for predictive maintenance, aimed at minimizing unexpected downtime of equipment. In this example, I would like to show you how unexpected downtime can disrupt operations and has major impact on terminal KPIs. During a loading operation of an RTG, unexpectedly, the spreader of the RTG breaks down. As a consequence, the broken RTG blocks the trucks, then the waiting key cranes, and finally the vessel. In order to avoid such a situation, we need a proper maintenance strategy to minimize the operational downtime of equipment. But what kind of maintenance strategies exist? The first one is the reactive or corrective maintenance. Suddenly, one of the RTGs is broken. We need a mechanic to come to solve the problem. This maintenance strategy is the most expensive due to unplanned operational downtime. The repairing usually is performed at the point where the equipment fails. The second strategy is the preventive or planned maintenance. For this maintenance strategy, we define regular time intervals where the RTG should be maintained. When the time comes, the RTG is prepared for maintenance and the mechanic comes to perform the maintenance. This maintenance strategy is driven by operational working hours. It is more beneficial than the reactive one. Still, main issue with this maintenance strategy is that it can sometimes result in unnecessary maintenance, increasing the cost. So, can we do it better? Yes, we can using predictive or condition-based maintenance. In this case, there is a need to install sensors on the RTG to give an indication if a problem occurs. When the sensor spots an issue, the spare parts can be ordered and the repairing can be scheduled in order to minimize the impact on production. This maintenance strategy is determined by condition of the equipment and not by the average expected lifetime of the equipment. But how can we realize this potentially best maintenance strategy? As a first step, we take all RTGs and all spreaders and start collecting data from sensors to identify irregular behavior of machinery. All spreader sensors are generating data. Those data are preprocessed using a preprocessing module and stored in a table. The table has columns representing the spreader sensors and one column representing the event. The event indicates if a failure occurs or not. One of the challenges is to find the patterns that indicate that a failure occurs. But how can we find those patterns? Let me show you an excellent approach for pattern recognition called machine learning. First, we collect all sensor and event data from our spreaders. These sensor and event data are the input for the machine learning algorithm. This algorithm analyzes all the patterns between the sensor data and the corresponding event data. Based on that, it's going to generate a predictive model. But how are we sure that this model is good enough? We continue to further collect sensor and event data from the spreader. The predictive model is using the sensor information as an input, and based on that, it will predict an output event. Then we validate the output event against the real event. This will result in the accuracy of the model, namely how good the prediction is. But how can we use this predictive model? Remember, our main goal is to minimize the unexpected downtime of equipment. We would like to keep the equipment up and running, but still minimizing the total maintenance and repair costs. In this small example, we use three different costs. First, inspection costs, which means one-time inspection of the spreader. Second, predictive maintenance costs. After predicting a spreader failure, it involves just the repairing costs. And finally, the corrective maintenance costs, which involves both the repair costs and the cost of operational downtime. In this example, the testing dataset contains 25,000 sensor entries, from which 1,162 failures. How can we predict the unexpected failures and still keep the maintenance and repair costs as low as possible? In the first scenario, we are using reactive maintenance. In this case, there is no inspection and no predictive maintenance applied. Therefore, the total maintenance and repair cost is the total corrective maintenance cost, which is the total number of failures times the cost to carry out the repair plus the cost of the operational downtime. Before applying predictive maintenance, let's revisit our data and the way the predictive model makes prediction. We distinguish four cases. In the first case, the predictive model predicts 0 and the actual event value is also 0. So there is no problem at all. No action is needed. In the second case, the predictive model predicts 1 and the actual event value is also 1. So there is a problem and the model predicts the need for maintenance or repair. This is a true positive. In the third case, the predictive model predicts 0, and the actual value is 1. So there is a potential problem, but the model is not predicting the problem. In this case, corrective maintenance is needed. This is a false negative. In the last case, the predictive model predicts 1, and the actual value is 0. So there is no problem at all, but the model gives a false request for a maintenance or repair. In this case, we consider it as an inspection. Now let's see what are the results after using the predictive model with our test data. After running our model with the test dataset, we obtained the confusion matrix, which describes the results of our predictive model. Based on the above results, the total maintenance and repair cost is significantly reduced comparing to the case when we used reactive maintenance. However, the model still has an issue. The occurrence of corrective maintenance is still pretty high. Can we further reduce that? In order to reduce the occurrence of expensive corrective maintenance, we further improve the machine learning algorithm and adjust the learning threshold to minimize the false negatives. After that, we obtain a second predictive model. A negative consequence is that the number of inspections significantly increased and the model is less accurate. Anyway, the expensive false negatives, which represents the expected number of corrective maintenance, were significantly reduced. As a consequence, the total maintenance and repair cost is also reduced. Comparing the three scenarios, we can conclude that after applying predictive maintenance using machine learning, we potentially decrease the total maintenance and repair costs. I would like to highlight that in order to properly apply this methodology, it is essential to have the right sensors that systematically register their values and the systematic registration of maintenance activities. Thank you very much for your attention.
Well, thank you, Csaba, for that final presentation. Really interesting to see how AI can be used in predictive maintenance. We've got a lot of questions that have come in during the presentation, so I'm now going to invite all the speakers onto the stage to go through some of the questions that have been submitted. So we'll just take a couple of seconds for everyone to join me on the screen now. Hello, Eva. Hello, hello, Oscar. And
Hi.
Hi.
Hello. Thank you, everyone, so much for your presentations. The audience has sent in quite a few questions, but before we head over to those, the theme of the webinar was artificial intelligence and resiliency. So just quickly, maybe each of you, starting with Robbert, how do you think artificial intelligence can be used best to make ports resilient, especially in times of crisis?
Thank you for your question. So, in my opinion, ports need to look into the data they have, because the most important thing is the garbage in is garbage out statement I made before. So if you want to improve your port operations, look at the data you have, start working on your data management. I saw it somewhere in the questions also, or your data standardization. And once you have that in place, you can start reaping benefits from learning from your models.
And Eva, same question to you.
Artificial intelligence is not only machine learning, it might be as well operations research as an example. And you can cope with bigger disruptions by just being, for example, infrastructure light, because you use, for example, optimization. And you can also handle micro disruptions which just occur during the daily business. Optimization in general just helps you to be more agile, and by not investing too much into infrastructure, the terminal can kind of breathe. That supports your management, your crisis management as well.
And Oscar?
Well, I would say along the same lines, right? I think that this is all about decision making in our case. Data-driven decision making. So what AI and machine learning and so on will help is to be better and more accurate and more effective with those decisions. Today we have a lot of data, but the data is not available to really apply AI or machine learning, right? And that's where we had to work on. And that's what when we really realized the power of AI and machine learning to really improve the way decisions are taken in our industry.
And finally, Csaba, what do you think?
Well, I think in the first place, the container terminals should ask themselves, what is my problem? So before applying any fancy solution, you should have a problem. And what I say always, if there is a possibility, have an analytic approach. And if you cannot solve it with an analytical approach, then use it, learn from the past. And that's machine learning. So collect data if there is a possibility on the terminal, or use existing data, but maybe you have some legacy data that you cannot use. But I think the biggest advice that I could give to container terminals, that should invest in the future, innovate. Now we are in the crisis moment, but I think in a couple of months or year, we will see it's going to be better. And I think that's the future.
Brilliant. Thank you for that insight, everyone. So one of our first questions came through for you, Robbert, but I think it's kind of applicable to everyone, and that is data standards. So the question says, how do you see the lack of standards hindering an effective implementation of port call optimization tools, which obviously make use of machine learning and AI? So Robbert, perhaps you could just start off, and then everyone else maybe have a think about this issue of standards. Obviously, we could have a whole other webinar on data standards. So, but yeah, let's explore that a little bit.
Yeah, sure. So looking at, for instance, the example I gave about AES data, that's something that's available already for a long time. So they're quite easy to start using it and applying it for AI, for instance. But looking at data standardization to start exchanging the data, it becomes more and more important also to not only talk the same language within your own company, but especially when working together with your partners or your port ecosystem. And there it becomes very important to speak the same language, which I think is the basics.
Eva, I know your presentation focused on data and the tools used to make the most of that data. Where do you see data standards fitting in?
I think it would help so much to make not every enterprise a new challenge, a new project, but we could rather more come in to companies, connect, exchange data, and go on. But by not having the standards for data, and also not the standards, we have standards for sure to interface, but still it's always quite a hurdle to get everything in place and to have this connection. If that would be easier for the customer, also the projects would be a lot less challenging and also a lot less money involving, probably.
Oscar, what are your thoughts on this?
Well, continuing on the same path, from the terminal side, more outside in is we still have important challenges to combine different data sources from different systems. And this seems to be very basic, but this is something we are lacking today, right? So that's a starting point. And more inside out from the terminal. The terminals today are really black boxes to the ocean supply chain. So we need to remove that current situation, and standardization is part of that. But in that path, the system provider has to help, opening the data, helping with better interfaces and more standard interfaces, and having the same language, but also the way and the mechanism to communicate for better interoperability between systems. Today, we are lacking that, even the basics.
And finally, Csaba, what are your thoughts on the issue of data standards?
I think it's a must. It was expressed by the colleagues, but it will be really difficult between the terminals, especially because of competition. And they have to sit down and to make some tasks there. But as Eva presented with containerization in the 60s, it happened. So why cannot happen again? In case of machine learning, I think it's really a must. In the presentation I gave regarding predictive maintenance, when you have seen that event, and that's the maintenance information. Can you imagine how the maintenance is happening today, how they register the maintenance in the container terminal today on paper, different formats? And in order to apply this kind of techniques, that's really a must. So I think it's absolutely needed.
Excellent. And I think another interesting question that we got through was, so it says, what standards are you using to verify the quality of your machine learning solutions in ports, as well as the minimum data quality assurance? So I think, and how do shipping companies play their part in the system? So I think that's kind of a question for everyone as well. So Robbert, let's start with you again. How do you assure quality within your solution, and shipping companies, how do they join in the conversation?
Yes, what we do, we together with the engineers, we get in domain experts, which is, I think, a very common approach. And with them, we try to sort of set the standards and sort of raise the bar. So when is it helpful for you? When are these machine learning models and the outcome of these ones actually helping you? In what situations isn't it? And the same applies also looking at carriers. So the domain knowledge can come from people on the ground in terminals. It can be from nautical services, but it can also be shipping lines. And one of the examples I'd like to give is we created a prediction model, and after a couple of weeks we found out that something was going wrong. And talking to one of the shipping lines, he said, "Yeah, well, but we actually went before going through the canal in between France and the UK, we actually get a pilot on board to help us with that." And that is something that we did not see due to the data. We saw some strange anomalies, but actually, well, you need to talk to the domain experts to get that input in to actually improve your model, and that's what we did.
And Eva, how are you tackling the quality assurance, and then how do you bring shipping companies and the wider supply chain into the machine learning aspect?
We always use machine learning models which keep us kind of in the loop so that we don't have any black box situations. So we can always kind of retrace why was knowledge gained the way it was gained and what are the reasons for that. And we do this, for example, to improve the stacking in huge container terminals. And there we have, let's say, the shipping information, but more kind of second-handed. So because we have this data in the specific containers, yet we don't have, let's say, the cooperation between the port and the shipping line and get the data before they kind of enter the port.
Okay. And Oscar, what are your thoughts on how the shipping companies can play a part in the system overall?
Well, I want to leave a positive message, right? So I see very important efforts in that direction. The new Digital Container Shipping Association is an example. They are defining data model APIs, all these specific components that are really necessary for the different processes. But the current reality is that today we don't have let's say that we have a way to evaluate how good are our decisions and our data area by area, but we don't have a way to connect all the areas together, like with the planning processes that I explained, right? So I think that in our case, what we are working on, but we didn't achieve that yet, is work on the data structure. That's fundamental. And for that, we are talking about 5 or 7 different systems together. And that's something that, that we need to work with different suppliers. And that's where the challenge is. So working towards that, but still we don't have a good way to correlate and to connect all the decisions together.
Eva, I saw you raise your hand. Do you have something you wanted to add?
Since we are also part of the container exchange route, there it will change, because then you will have the data also from all the shippers together and the bookings, and then make plans with those to see also the exchange of data between the different ports. So that will be really exciting to see how we can benefit from this really, really broad initiative.
Absolutely, that is a very interesting project, but the terminal itself will continue being a black box for jet planning, bed planning, and intermodal planning. I don't want to sound negative again, but we have a lot of work to do, and I see, let's say, steps on that direction, but still the reality today is not that.
Yeah, and Csaba, finally, your thoughts on the topic?
Well, I think we should also rely on experts, so giving opinion and working together, as was expressed by Oscar, to define the,
And a question from Chuck Schneider for Oscar. One of your slides during your presentation on constraints, the data system of record must be put together by someone who should own this. Hope that makes sense to you, Oscar.
Well, thank you, Chuck. I'm happy to have a question from you. Well, I would say that the system integrator role is a missing piece in the terminal, for the terminal operator, right? So that system integrator role should get focused on data management. I think Eva explained very well how important it is to have data, good practices in place, data structure, and so on. So I think that we are looking for that role to be fulfilled by someone. Right now, and I am talking as a terminal operator, we are getting too much into developing our own systems and taking too much ownership on developing technology. I would not like to do that, but we don't have a chance to really find a partner that can connect the dots for those 7 or 10 different systems and create that data system of record. So that's something that will need to be resolved in the coming few years to be able to be effective, not only with AI, but I would say in general with data analytics and the good use of data. We are still having these baby steps. Again, positive on the progress on companies from like TVA or Inform, but still for the terminal operator is too complex. And we are getting too much into the technology supplier side.
Okay, thank you for that. So this is another question for everyone, I think. Based on your experience from like your different points of view, how usable is historical data sets that are available today? The question says that they've grown over the years with like limited data management strategies often. So what kind of data management is going to be gaining visibility, and kind of how do you see data evolving? Perhaps Eva, we could go to you first, as you spoke a lot about data and the tools needed.
I think there are a lot of questions to solve. One is how can we make or assure that the software systems generate clear data, so that we already by designing the software systems think about the future that we want to get this data, and perhaps even data we are not thinking of valuable today, and we want to have this data later to use it. Then the other part, and I think that will be an important question in the future, is do ports want to do their own data management, or do they want to hand it over to a third party? And if they do their own data management, how can they structure it? How can they get the necessary knowledge? We see today, even if you're a data analyst, if you put a very capable data analyst in front of data, this person probably can't do anything because they need so much background knowledge to get this riddle of data, a clear picture from it. So I think the historical data is valuable, but it's like archaeology. So you really have to invest a lot of knowledge and a lot of energy to get a clear picture out of that.
Robbert, what do you think about this kind of historical data and like how we go forward?
Yeah, so what I like to add is that it's quite difficult to sort of manage your data if you don't know what you want to get out of it. So also often you see it's very important, and I think that Csaba also mentioned it also in his presentation, that you need to have an open mind to what the solution is you want to get to, and based on that you can look at the information that you need to come up to that solution. So it's something that you need to set up the governance, you need to have people in place doing that, and it's something that will grow over time. It's not something you can do once and then you're done. It's something that will grow.
And Csaba, from TBA's point of view, what do you think?
Well, I think we are collecting, we are generating today a lot of data worldwide. If I take just only the RTGs with different kind of sensors. And I think a really wrong approach if people try to solve certain problems and to use what I already told you before, machine learning and just relying on legacy data. So it is very important to have the right data. And that's not only for the port business, but that's really one of the biggest challenge from the machine learning, to have the right quality of the right amount of data and the right quality of data. And you can have only the data if you are designing or you are making the system to collect those data. And in order to do that, you need to know what you want to solve. What is your really problem? And I think that's very, very important, especially if you are designing a new system, a new equipment, a new solution. Think about generating the right amount and right quality of data.
And finally, Oscar, what are your thoughts on this?
Well, maybe it's a repetition for what my three colleagues mentioned. I think that to Robert's point, we need to know what we want to understand from the past, right? I think Eva also mentioned, right? When we know what we want to understand from the past, then we need the data from the different systems. The data from the different systems, most of it is not persisting today. What that means, for example, for the yard, we know the historical data that we have in the yard, but we are not able to predict the future because some of this data is not persisting or not accurate, right? So I think that we need to know what we want to predict, basically, have the data to do so, and then connect with the current processes. The ETA or the yard next transportation modality are just two examples. But focusing on those use cases, we will be able to create also the practices to connect the use case with the data that we need and also the application of that prediction. That, I would say, what I add for what my three colleagues mentioned already.
Yeah. Okay, and now a question directly for Csaba. How is it possible to utilize machine learning in maintenance without investment in adding extra sensors to equipment and only using normally available machine data? So is it possible to do this without overhauling equipment? You mentioned like the sensors that would be needed at the end of your presentation, I think.
Well, you have to learn from past. You have to learn from past. If you can learn from something else than sensor data, that's fine. You can, but you have to understand if something, a fault occurs, so there is a maintenance. You have to understand why that happened,
And if you can build a pattern based on that data, in my case, in my presentation, I mentioned sensor data, but can be any kind of data, then of course you can use it. But the most logical way, and this is the future, the IoT. So using sensors that are reporting different kind of real life data, temperature, humidity, and other kind of information. So I say it's possible, but that's not quite common. Usually they use sensor for data.
And just a follow up.
Yes.
Oh no, hang on. No, this one's for Oscar. How do you overcome the challenge when some may not want to open up their interfaces?
I think we lost you, Beth.
It's frozen.
Yeah.
I didn't fully understand the question. Sorry.
I guess Beth has to reconnect.
Apologies for that, everyone. I think everyone understands that people have been dropping out on different webinar calls.
Seems we lost her again.
We can ask ourselves questions.
Yes, indeed.
Apologies for that, guys. I should be back now. I think, given that we have around 5 minutes left for the question and answer session, I think maybe it would be a good opportunity actually to go through everyone's kind of key takeaways as speakers, what you think might be the key things that our audience members can take away from today's discussion. Obviously, we've tried to get through as many questions on the live question chat as possible. So, Eva, what do you think would be the key messages to take away from today's discussion, bearing in mind the theme of artificial intelligence and resiliency for ports?
I think artificial intelligence can be a really, really great tool, or it is a great tool, but it needs its resources, which are data. But I think we also have to kind of narrow our focus a bit to machine learning and our problems with getting the right data. But I think artificial intelligence, we would have to have a broader look and also have a look what's coming up during the next decade, let's say, and how is 5G. I mean, when 5G starts, we will get even more data thrown at us. And also it will change the habits of how do we use data, how do we cope at a terminal. What will happen if we look at the whole thing more as a cyber-physical system where, let's say, artificial intelligence and humans work very close together? How will that shape our working, our abilities, our need for learning and for cooperation as well? So I think we shouldn't get stuck too much in this. We don't have the best data. Yes, we have to overcome this, but this can't be the whole picture.
Thank you so much, Eva. And Csaba, what do you think, closing remarks on some of the topics we've covered today?
I would say start small for all the container terminals. So think big, but start small with a small case, small problem, and invest in your terminal. And I truly believe that artificial intelligence will be the future for container terminals. Now we are that conservative market, but what we can see now in car industry and in other industry, it's really speeding up. And I think it's good to understand and to start collecting data and starting with small projects. That's my advice.
And Robert, the same question to you. What are your kind of closing remarks, and what are some of the things that people should be taking away from today's discussion?
Yeah, there's a sort of a gap between getting the results, but also focusing on the standardization part, which sometimes can take years or even decades to get that done. So I agree on the approach that you want to realize the benefits, because with then you can build the business cases also for your standardization efforts. So you want to start achieving results in a small way. And on the other hand, you also want to have still focus on the big overarching goal where you want to go to, and basically you need to have the standardization available there. So indeed, I'd like the start small approach, and get some ideas running, and get some solutions where you want to focus on using AI. But on the other hand, also focus on the long-term operational implementations. Do not forget that.
Thank you. And finally, Oscar, over to you. What do you think the key takeaway should be?
Well, I think this is a very relevant topic for the coming years, and it's happening. So maybe my message sounds a little bit negative, but it's happening, not maybe with an end-to-end approach, and that's why my remarks regarding the data, matching with EVAs on data management and so on. But I think we have to be positive on this. Second, I think that we need that ecosystem mindset to be able to create value from AI in the coming years, and that's not happening today. We are still driven by commercial strategies, and we don't have an ecosystem that can be standardized. So that's the second. And then the last one is that this is a multidisciplinary area, right? I think that I am talking about decision making, and what I am explaining is something we are doing. It's not just marketing, but we need to combine the decision making practices today with the human thinking, right? Because it's not about replacing people for machine or algorithms, right? It's about combining and finding synergies and finding evolution, right? So I think that deep dive on the human thinking and create evolution on the current roles, but also the future roles will be very important. And we need people to take care of the data. We need people to take care of the algorithms. So my final message is that I don't think that jobs will be removed. It will be the opposite. I think that we will see a new competence and new roles and new people that will need to step in the terminal and the carrier side. That's my view on this.
Well, thank you everyone for joining in the webinar. Obviously, especially thank you to our speakers for staying around for the live Q&A. I think that's always adds such value to these kind of webinar sessions. So for everyone that did send a question, thank you very much. And what we will be able to do is we'll be able to send some of these questions over to our presenters for them to answer when they have the time. Once again, I would like to thank our sponsors, Inform and TBA, as well as Robert and Oscar for joining us on this webinar and providing some excellent insight into the theme today of artificial intelligence and resiliency. If you're interested in attending another PTI webinar, we have one coming up tomorrow at the same time on port-centric logistics. Also, if you head to our website, you'll be able to find our full schedule of programs coming up. We're always looking for new webinar ideas, so please do get in touch with the team. Head to the Port Technology website where you'll be able to send an inquiry in if you have any ideas for topics we should explore in the future. But as always, thank you so much for joining us. Thank you for sending your questions, and thank you to the speakers for spending your time with us today.
Thank you.
Thank you very much.
Thank you very much.
Yeah.